Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to be going through question number 9 from the specimen paper for the IGCSE Cambridge 0580. This is paper 2, the non-calculator paper, and this question is about sequences. And we're told here that T1 equals 17, T2 equals 12, T3 equals 7, T4 equals 2. T here stands for the term, so that means the first term, the second term, the third term, the fourth term. Sometimes you're given them in terms of U, so you have U1, U2, U3. In this case, we're given in terms of T, right? So basically, we have a sequence like this: 17, 12, 7, and 2. So the sequence is changing from term to term, and we can see that there is some sort of pattern to it. If you want to find out that pattern, what you can do first, it's quite obvious what it is here, but you can see how do you get from one number to the next number. Well, from 17 to 12 you have to subtract 5, and from 12 to 7 you have to subtract 5, and from 7 to 2 you have to subtract 5. So obviously that's the pattern. To get to the next term you have to subtract 5, so the fifth term, which is the next term, is going to be -3. So that's the first part done pretty simply. And then it says Tn, which means find the nth term. It means the algebraic formula for any term that you want to find. So the nth term can be found in the following way. This is called a linear sequence, because the first row of differences, what we found here, is a constant. To get from one term to the next term, you have to add or subtract the same number. In this case, you have to subtract the same number each time. All right, so when something changes in that way, then it has some link to the times table of that number that you're adding or subtracting. So for example, the 3 times table, 3, 6, 9, 12, and so on. It goes up by 3 each time. So it's got something to do with 3 times n. What's happening here to my pen? Sorry. In this particular case here, what we can do is you can see it's going down by 5 each time. 17, 12, 7, 2, and so on. So if it's going down by 5 each time, then it's got something to do with the -5 times table. So we say -5 times n. That makes something going down by 5 each time. So the first term of this sequence would be -5, then it would be -10, -15, -20, and so on. But we don't want it to start from -5, we want it to start from 17. So it's like we have to drag this all the way up to 17 by adding, well, what's the difference between -5 and 17? 22. If you add 22 to -5, you get 17. It's like you're at -5, you want to get up to 17. Again, using the calculator is not allowed in this exam, so you have to understand how to do this. If you're not sure, you think about directed numbers, which some students do have difficulties with. You want to go from -5 to 17, you've got to go up 5 to get to 0, and then you've got to go up another 17 to get to 17. 17 plus 5 is 22. So you've got to add 22 to that, and that is the nth term. Now we can write the answer as -5n plus 22, or we can write the answer as 22 minus 5n. Both of those are fine. And if you want to make sure, you can test your answer. For example, let's choose the fourth term. Okay, T4 we know is equal to 22, so is equal to 2. But if we use this formula for T4, we're going to put n, instead of n we're going to put 4. So it's 22 minus 20, which is 2, so we can see that that works. So we know that that is the correct answer. Alright, so that's how you can use, or you can find the nth term of this. This is a linear sequence, alright? So there's other ways for geometric sequences and for quadratic sequences. Geometric sequences are also known as exponential sequences. Alright, so there's different methods that we use for them, and when we get to questions of those types, we will go through those. But this is a simple question on linear sequences, pretty much straightforward. So that concludes this question. Other questions from this particular paper can be found in the playlist that will appear in this section over here. Other questions from the topic of number patterns and sequences you can find in the playlist that will appear in this section. Now that's for the new syllabus. For the old syllabus, there's a playlist over here which has the questions from the older papers, where sometimes calculators were used, but the concepts are still the same basic concepts of how to find nth terms and stuff. So you can watch other examples from the older papers there, and you can subscribe to my channel by clicking on this link. Thank you for watching. See you soon.